And welcome to learning how to use the ratios in order to determine the height of another object in a picture. And this is leading into our bubblegum blowing contest that we'll be holding shortly. So by now you should be in the LMS if you're accessing this video. And what the challenge is for this lesson is I've got this picture on the LMS of the downtown Toronto area, and obviously one of the big things that stands out is the CN Tower, one of those icons of Toronto. In this picture you'll notice that there's a variety of different buildings here on the waterfront. There's Rogers Centre, there's a few apartment buildings and business buildings here as well. So the challenge that's set forth here is this activity is going to get you ready for the culminating project that's coming up. So you're going to use this picture and you're going to use the real height of the CN Tower at 553 and 33 hundredths meters tall. You're going to use that information and this image to determine the size of any of the buildings here on the waterfront. So how does that work? Well, what I'm going to do is just give you an example, and I'm actually going to give you the height of one of these buildings here in the front. I'm just going to pick at random here, and that'll put this building off limits for anybody. I'm going to choose this little apartment building over here with the blue sides. So there's a few different ways of doing this, but what I'm going to show you is how to use this with Smart Notebook, which should be on the notebook laptops that you have with you. So first of all, I'm going to right click on this image. I'm going to copy the image, and then I'm going to go and I'm going to open up Smart Notebook. This is the icon that you'd notice for Smart Notebook. If you don't see that image, what you can do is you can just do a quick search on the computer, type in Notebook, and you should see the file to open this up. So I'm going to open up Notebook. Just takes a moment. Sometimes it's possibly open here already. I'm going to go a new file, and once Notebook is open, I'm going to paste in the picture that I just took off of the LMS. Now, again, you can see that the whole image is here. I'm going to scroll it down so that everything is in the picture. If you're having trouble seeing the entire CN Tower, what you're going to want to do is you can go to the View item, go to Zoom. You might want to start playing in maybe 75%. My view before was working just fine, so I'm going to go back to Zoom, and I'm going to put it at the entire page. So with this image up, there's a few things that I'm going to need to do. I know that the height of this tower is 553 meters. So 553 and 3300 meters. Now, something else that I know is that I want to get this little guy over here. So I'm actually going to just put a little shape around it so that I don't forget which item I'm going to be measuring. It's also a good idea for you if you were to submit the work that you're doing. This would be a good idea so that I would know what you're dealing with. So now I need to start working and thinking. The easiest thing that I could do is I could just use the content gallery, and I'm going to do a search for ruler, and I'm not going to use the imperial ruler because that's using inches. We are in Canada, so we're going to use the metric ruler. I'm actually going to just drag this right onto my page. Now what I can do is I'll go back and use my mouse button. I'm going to take this, and I'm going to flip it right on its edge. Now you'll notice that my ruler doesn't actually reach to the top of the CN tower. So I'm going to have to change the size of my ruler. That's perfectly okay, as long as I don't change the size of it again. So I'm going to make it so that it's large enough to measure the CN tower. And it just so happens that this is going to work out to be about a perfect 10 centimeters. And it's not really centimeters, it's just a ratio that we're looking at. So to make sure I don't change the size of it, I'm going to go in here, I'm going to actually lock this. I'm going to allow move and rotate, but it won't let me change the size of it now. So now I've got a ratio for the CN tower. So I'm going to actually go here, I'm going to view, I will work with a smaller size here. I'm going to go to 75%. And down here I'm going to start creating a ratio table. So I'm going to have my ratio table. And I'm going to start labeling my ratios. So first of all, I know that I'm going to take the CN tower. And of course, I'm also going to add on my apartment building. I'm actually just going to make that smaller so that it puts it into two different heights there. The CN tower, we're going to take it and I'm going to place it down here as the finished number on my ratio table. Now you'll notice that I also took this ruler, I've now moved it off to the side, and I'm going to use it to measure the height of my building down here. So just to make sure that we can get an accurate measurement, we'll just take a closer look on this. And it looks to me like this is actually going to measure in at about 0.8 of these units here. So if I scroll out, I can say that my apartment building here has got a height of 0.8 of these units, no matter what they are. It doesn't really matter what the unit is, because we're just setting up a ratio just to tell us how many of these pieces are going to fit for the apartment building will fit with the CN tower. So now I'm going to take my measuring device and I'm going to actually use it with the CN tower. So I'm going to put it here, and it actually looks like it's going to work out quite nicely at the 10 units. So I'm going to put that number in here. So what that's telling me is for every 10 of these units on the CN, for every one of these measuring units, it'll take 10 of those to give me the height of the CN tower on the image, and only 0.8 of those to give me the height of the apartment building. So now the question becomes, how did this 10 become 553.33? Or another way of looking at it is, how many times does this fit into 553.33? Whenever you have that set up as a how many times does that fit in, that means it's a division. So I'm going to take 553.33, I'm going to divide that by 10. And we should be able to do that without a calculator, but if you did use a calculator, you'll notice you'll get 55.3. So what that means is right here, I need to be multiplying. I'm going to set this up as a big font. I need to be multiplying by 55.3. Now, there is one saying that we've been having as we've been working with these ratios, and that is what I do to the top, I also need to do that to the bottom. So I'm just going to actually clone this so that you can actually use that and put it here. So I already know that 10 times 55.3 is going to give me this number. But in order to keep the ratio the same, we have to obviously multiply by the same amount. So now I need to do 0.8 times 55.3. So I'm going to go 0.8 times 55.3. It gives me an answer of 44.24. So that tells me that in real life, this building, according to the measurements that we've taken, would be 44.24 meters. Not monkeys, even though it's an M, it's meters. Hope this has been helpful for you. And again, you can use any of the buildings here on the in this image, But this little guy here in the corner is now off limits since I've given you the actual answer to that. Good luck.